All right, so today we are going to be looking at exponential growth. Exponential growth is when a quantity increases by a fixed percent each year. To the left here, we have the exponential growth formula, which is y equals a times 1 plus r to the power of t. So let's go ahead and look at what exactly do these variables represent, okay? So we're going to do them by color. So A is going to be representative of the initial value or the initial amount, okay? So initial value, and I'm going to put the word amount in parentheses. So the initial value / amount. R is going to be representative of the growth rate, since we're talking about growth. All right, so it's the growth rate or the decay rate, but in this particular situation, we're talking about growth rate. Okay, so that's the amount that it grows, and then it's also represented by a decimal. Okay, a percentage that comes in the form of a decimal. All right, and then we have the letter T, all right, which is going to be the number of time intervals, right? So it depends on what the actual problem is talking about or the word problem is talking about, but it is going to be the initial time. All right, so let's go ahead and look at our word problem. It says in 1990, the cost of the tuition at a state university was $4,300, $4,300. So I'm going to highlight that in yellow. All right, to show you that that is the initial amount because my initial amount is also highlighted in yellow. Okay. During the next 8 years, the tuition rose 4%. So 4% would be the growth rate. Okay. 4% would be the growth rate. Now, in this case right here, we are not sure what the amount of years is going to be. So we do not need to put anything for the letter T. All right, so I'm going to write a model, meaning I'm going to take this information that I highlighted in the word problem and I'm going to substitute it where the variables go for that particular situation. So we have y equals A is 4,300. All right, times 1 plus, and then the growth rate is 4%. We need to put it as a decimal. So that's going to be 0.04. All right, and we're going to do to the power of t. All right, so as you can tell, I've substituted my value for A and my value for R. Okay, I have substituted my value for A and the value for